Cross-connections of electric and magnetic force. Circuital flux. Circuitation. 33. The two sets of quantities, the electric and magnetic forces, with their corresponding fluxes and currents, and the connected products and ratios, may be considered quite independently of one another, without any explicit connection being stated between the electric set and the magnetic set, whether they coexist or not. But to have a dynamical electromagnetic theory, we require to know something more, viz., the cross-connections or interactions between E and H. Or, in another form, we require to know how an electric field and a magnetic field mutually influence one another. One of these interactions has been already partially mentioned, though only incidentally, in stating the meanings of permeance and inductance. It was observed that the electric current in a simple conductive circuit was measured by the gaussage in the corresponding magnetic circuit. A word has been much wanted to express in a convenient and concise manner the property possessed by some fluxes and other vectors of being distributed in closed circuits. This one has been recently supplied by Sir W. Thomson's introduction of the word circuital for the purpose. Thus, electric current is a circuital flux, and so is magnetic induction. The fundamental basis of the property is that as much of a circuital flux enters any volume at some parts of its surface as leaves it at others, so that the flux has no divergence anywhere. This qualification, anywhere, should be remembered for a flux which may diverge locally, as, for instance, electric displacement, is not circuital in general, though even electric displacement may be circuital sometimes. Further, as a flux need not be distributed throughout a volume, but may be confined to a surface, or to a line, we have then specialized meanings of circuital and of divergence. Or a volume distribution and a surface or line distribution of a flux may be necessarily conjoined, without, however, any departure from the essential principle concerned. The word circuital, which will be often used, suggested to me the word cercuitation, to indicate the often occurring operation of a line integral in a closed circuit. As, for instance, in the estimation of circuital voltage or gaussage. Now, in the case of a moving fluid, Sir W. Thomson called the line integral of the velocity in a closed circuit the circulation. This is curiously like circuitation, but circulation seems to have too specialized a meaning to be suitable for application to any vector, and I shall employ circuitation. The operation of circuitation is applicable to any vector, whether it be circuital or not. First law of circuitation. 34. Now, in the case of a simple conductive circuit, we have two circuital fluxes. There is a circuital conducting course supporting an electric current, and there is a circuital flux of induction through the conductive circuit. In the electric circuit we have Ohm's law. E equals RC, where E is the circuital voltage, C the current, and R the resistance. And in the magnetic circuit we have a formally similar relation. H equals L to the minus 1 power times B, where H is the circuital gaussage, B the induction, and L to the minus 1 the reluctance. Or B equals LH, where L is the inductance or the permeance, when there is only one turn of wire. Now, the cross-connection in this special case is implied in the assertion that H and C are the same quantity, when measured in rational units. The expression of the law of which this is an illustration is contained in any of the following alternative statements. The line integral of the magnetic force in any closed circuit measures the electric current through any surface bounded by the circuit. Or, the circuitation of the magnetic force measures the electric current through the circuit. Or, the electric current is measured by the magnetic circuitation, or by the circuital gaussage. The terminology of electromagnetism is in a transitional state at present, owing to the change that is taking place in popular ideas concerning electricity, and the unsuitability of the old terminology, founded upon the fluidity of electricity, for a comprehensive view of electromagnetism. This is the excuse for so many new words and forms of expression. Some of them may find permanent acceptation. The above law applies to any circuit of any size or shape, and irrespective of the kind of matter it passes through, meaning by circuit merely a closed line, along which the gaussage is reckoned. By the current is to be understood the current, not merely the conduction current alone, or the displacement current alone, but their sum, the convection current term, will be considered separately. It is also necessary to understand that a certain convention is implied in the statement of the law regarding positive senses of translation and rotation when taking line and surface integrals. Look at the face of a watch, and imagine its circumference to be the electric circuit. The ends of the pointers travel in the circuit in the positive sense, if you are looking through the circuit along its axis in the positive sense. Also, you are looking at the negative side of the circuit. Thus, when the current is positive in its circuit, the magnetic induction goes through it in the positive direction, from the negative side to the positive side. Otherwise, the positive sense of the current in a circuit and the induction through it are connected in the same way as the motions of rotation and translation of a nut on an ordinary right-handed screw. This is the Vine system used by all British writers, but some continental writers use the Hop system, in which the rotation is the other way, for the same translation. It is useless trying to work both systems, and when one comes across the left-handed system in papers, it is, perhaps, best to marginally put the matter straight, and then ignore the text. Second Law of Circuitation. 35. The other cross-connection required is a precisely similar relation between voltage and magnetic current, with, however, a change of sign. Thus, the negative line integral of the electric force in any circuit, or the electric circuitation, measures the magnetic current through the circuit. Or, the voltage in any circuit measures the magnetic current through the circuit taken negatively. Or, magnetic current is measured by the circuital voltage reversed, and other alternative equivalent statements. Definition of curl. 36. In the above laws of circuitation, the currents are the concrete currents, surface integrals, and the forces also the concrete voltage or gaussage. When we pass to the unit volume, it is the current density that is the flux. The circuitation of the force is then called its curl. Thus, if J be the electric current and G the magnetic current, the two laws are curl H1 equals J minus curl of E1 equals G, where E1 and H1 are the electric and magnetic force of the field. We may now say concisely that the electric current is the curl of the magnetic force. The magnetic current is the negative curl of the electric force. There is nothing transcendental about curl. Any man who understands the laws of circuitation also understands what curl means, though he may not himself be aware of his knowledge, being like the Frenchman who talked prose for many years without knowing it. The concrete circuitation is sufficient for many problems, especially those concerning linear conductors and magnetic theory. But it does not suffice for mathematical analysis, and to go into detail we require to pass from the concrete to the specific and use curl. How to manipulate curl is a different matter altogether from clearly understanding what it means and the part it plays. The latter is open to everybody. For the former, vector analysis is most suitable. Let a unit area be chosen perpendicular to the electric current J. Its edge is then the circuit to which H1 belongs in equation 4. The gaussage in this circuit measures the current density. Similarly, regarding equation 5, the voltage in a unit circuit perpendicular to the magnetic current measures its density negatively. In short, what circuitation is in general, curl is the same per unit area.